discuss the jet transformation, and then I will discuss the properties of the jet transformation, and we'll try to find out the jet transformation of some standard problems. And jet transformation is basically used to solve the difference equation. And first of all, let us discuss the one-sided jet transformation, and then we will discuss the two-sided jet transformation. So jet transform, this is your one-sided. So let un be the sequence defined for the discrete values n equal to 0, 1, 2, 3 and so on, and let us assume that un is 0 for your negative values of n. So let un be the sequence of numbers defined for the discrete values n equal to 0, 1, 2, 3 and so on, and your un is 0 for n negative. Then here our un is right-handed sequence because we are taking n as 0, 1, 2 and so on. Then the jet transformation of un is denoted by u of z is equal to n equal to 0 to infinity un z to power minus n. So this is the definition of the jet transformation of un. The jet transformation of un is equal to, say, some uz, which is a function of z, because here we will have the terms of z. So this jet transformation of un is uz, and this is equal to this summation. From here, the inverse jet transformation will be the sequence un. So this is your inverse jet transformation, and the region of convergence of ROC, the region of convergence of this jet transformation is the circle, say, is the circle mod z greater than mod a. That means the region of convergence is the outside portion of the circle. So this is the radius, and that means your region of convergence is this portion. So the region of convergence is outside the circle. Now if the sequence is left-handed, that means when it is defined for the negative values, then your ROC is, then region of convergence is inside of the circle, say mod z less than mod b. That means mod z less than mod b means your inside region of the circle. So this is the definition of one-sided jet transformation. And let us discuss the two-sided jet transform. So the two-sided jet transform is, now let un be the sequence defined for the discrete values, then the two-sided jet transform is jet transform of un is equal to jet transform of this sequence small un is equal to u of z equal to n equal to minus infinity to infinity un z to power minus n. This is your jet transformation, two-sided jet transformation, and here and region of convergence will be the annular region of the circle, say mod z less than c and mod z greater than mod b. So that means this annular region will be the ROC. This annular region will be the region of convergence of this particular jet transformation of this particular sequence. So this is your region of convergence, where your mod z is less than c and it has to be greater than mod b. That means the annular portion. Now let us find out the Z transformation of note, or you can say that the Z transformation of 8 power n, assuming that n is greater than or equal to 0, is equal to z upon z minus a, where your n is either 0 or greater than 0. Proof. So Z transformation of 8 power n is equal to, let us use the definition. This definition is from n equal to 0 to infinity, then we will have un means 8 power n into z to the power minus n. Z transformation of un is equal to n equal to 0 to infinity, un into z to the power minus n. Now if you put n equal to 0, we will get 1. At n equal to 1, we will get a upon z. For n equal to 2, we will have a square upon z square, and so on. So this is your geometric progression. Now the sum of the infinite terms of Gp is equal to a upon 1 minus r, and it converges when your common ratio is less than 1, and the convergence is when your mod a upon mod z is less than 1. So only then this infinite series will converge. So this is equal to your z upon z minus a, and your ROC is mod z is greater than mod a. So mod z is greater than mod a means the outside portion of the circle. Now if your n is 1, if your a is 1, then the Z transformation of 1 will be, put your a as 1. So your Z transformation of 1 will be, here use the capital Z, and this one is your small z. So the Z transformation of 1 is Z upon Z minus 1. Now we have the formula. The Z transformation of, if the Z transformation of un is uz, then the Z transformation of nun is minus z upon minus z by dz of uz, or you can write it as uz, okay. And the Z transformation of n square un will be minus z d by dz of whole square of this uz, and Z transformation of n cube un will be minus z d by dz of cube of uz. So the Z transformation, if the Z transformation of un is uz, then the Z transformation of n times un will be minus z by dz of uz. Let us prove this one. So the Z transformation of n into un, now this will be equal to, now let us take the right hand side, and which is your minus z into d by dz of uz. So uz means the Z transformation of z, and the Z transformation of un is equal to n equal to 0 to infinity, then un z to the power minus n. Now if we differentiate this series, then we will get un, then differentiation with respect to z will be minus n into z to the power minus n minus 1. So this is equal to n times, this is equal to n equal to 0 to infinity, n into un, then we will have z to the power minus n. And you can say that this is the definition of, now in place of un we have n into un. So this is the definition of Z transformation of n un. So the Z transformation of n un is equal to minus z d by dz of uz. So we have proved the first part. Therefore, we can say that the Z transformation of any u1 is equal to the one-time differentiation minus z into d by dz of uz. Now let us compute the Zn square un. Now Zn square un. Now this can be written as Zn of n un. We can also write it as Z transformation of n into un. Now here you can see that the Z transformation of n into un, say this is your n and this is your un. Now the Z transformation of n into some n un, or if you assume this one as vn, suppose that this is your vn, where vn is n into un. Now by this formula, the Z transformation of n bn will be minus z d by dz of uz, where uz was the Z transformation of this vn, and that means Z transformation of vn, and the Z transformation of vn is, and the Z transformation of vn means nun, and the Z transformation of nun is again minus z by dz, so this will be your minus z d by dz whole square into uz. So this is your Z transformation of n square into un. Z transformation of n square un can be written as Z transformation of n into n un. Say n un is vn, then it will be your Z of n vn. Now Z of n vn will be minus z d by dz of the Z transformation of un. So this will be your minus z d by dz of the Z transformation of vn. And the Z transformation of vn means the Z transformation of n into un. And Z transformation of n into un is minus z d by dz of uz. So we have two powers of minus z d by dz, so this will be a square. Okay, suppose that, now from here, suppose that your un is 1. Okay, question, again note, the Z transformation of n, the first formula, find the Z transformation of n. Now this can be written as Z transformation of n into 1, where your, and if we assume this 1 as un, then this will be your Z transformation of n into un, and the Z transformation of n into un, the Z transformation of n into un was minus z d by dz of Z transformation of un, that means Z transformation of 1, and we have already given the formula for Z transformation of 1, which was your z upon z minus 1. So this will be your d by dz of z upon z minus 1. So this is equal to, now if you differentiate this one, then this will be your z minus 1, then minus z upon z minus 1 whole square. So this is equal to your z upon z minus 1 whole square. So the Z transformation of n is equal to z upon z minus 1 whole square. Now let us compute the Z transformation of n square. Now the Z transformation of n square will be Z transformation of n square. Now the Z transformation of n square will be minus z d by dz into uz. Uz means we can also write it as Z transformation of n square into 1, and if you assume this 1 as vn or un, then z square of n un will be minus z d by dz of whole square of uz, where uz means the Z transformation of un, and un is 1. So the Z transformation of 1, and which is your z upon z minus 1. This is your whole square, so that means this will be your, like this, of uz, and uz was z upon z minus 1. Because this is your whole square, so we will write it like this, and from here this will be minus z. Now this d by dz of this one will be, this will be z minus 1 minus z divided by z minus 1 whole square. So this is equal to, now this will be your minus 1, so this will be plus z upon z minus 1 whole square. Now its one more time differentiation will be, so differentiation of the numerator will be 1, then we will have minus sign into z, and then this 1 upon power 4. So this is equal to, now you can see that z minus 1 whole is 1, z minus 1 is cancelled. So from here we will have z minus 1 minus 2z upon z minus 1 cube. So this is equal to, now this will be your minus z minus 1, so this will be your z into z plus 1. So we can write it as z square plus z upon z minus 1 whole cube. So this is the z transformation of n square. And similarly we can find out the z transformation of n cube. Thus the z transformation of n is z upon z minus 1 whole square. Z transformation of n square is z square plus z upon z minus 1 whole cube. And then the z transformation of n cube will be minus z d by dz of whole cube into uz, where uz will be the z transformation of 1, which will be your z upon z minus 1. Okay. Next formula, the damping rule. So if your z transformation of un is equal to uz, then the z transformation of a power minus n of un will be uaz. So if your z transformation of the function un or sequence un is uz, then if you multiply this un by 8 power minus 1, then this z will get multiplied. So this is your u of a times z, and that is why we are calling it damping. So proof, let us start with uaz or with left hand side. So z transformation of a power minus n will be, use your definition, which is your n equal to 0 to infinity, then the sequence, and then z to power minus n. So this can be written as n equal to 0 to infinity un az power minus n. So you can see that we are getting az in place of z. So this will be your u of az. So this is your proof. Note, if we replace our n by minus n, then the z transformation of, or we can say that if we replace our a by 8 power minus 1, then this will be your 8 power n, un will be u a inverse z. This is when we have replaced our a by a inverse. So the z transformation of 8 power n un will be u a inverse z. Now from here we can have the z transformation of 8 power minus n. Note, z transformation of 8 power minus n, where your n is, here your n is greater than equal to 0. Now if you use this formula, then this will be your u times az. Then this will be your u times az. Now here uz means, the z transformation of un, and here we can also write this term as like this one, and that means this is your a power minus n into un. So here our un is 1. So the z transformation of 8 power minus n un will be u of az, where my uz means, is the z transformation of this un. And now in place of un we have 1. So this is your Z transformation of 1, and the Z transformation of 1 is Z1 Z minus 1. So therefore we will have to replace our Z by AZ. So your answer is AZ upon AZ minus 1. So this is your answer. For example, Z transformation of 2 power minus n. Now if you put A equal to, then this will be 2Z upon 2Z minus 1. Please note that here our n is greater than or equal to 0. Now if this n is not greater than or equal to 0, and suppose that if your n is greater than 0, then we will not get this answer, then this will be a different one. So this is your Z transformation of 8 power minus n. Then let us find out. Okay. Now let us find out the Z transformations of the standard results. Questions or formulae? Questions. Prove that the Z transformation of n into 8 power n is equal to Az upon Z minus a whole square, and all these are based on your damping rule. This will be Az square plus Az upon Z minus a whole cube. Then the third one, Z transformation of cos n theta is equal to Z into Z minus cos theta upon Z square minus 2Z cos theta plus 1. Then we have the Z transformation of sin n theta, which is equal to Z sin theta upon Z square minus 2Z cos theta plus 1. Then we have the Z transformation of 8 power n sin n theta, which is your Az sin theta upon Z square minus 2Az cos theta plus a square. Then we have the formula for Z transformation of cos hyperbolic n theta. This is your Z square minus Z cos hyperbolic theta upon Z square minus 2Z cos hyperbolic theta plus 1. And then we can have the formula for, similarly we can have the formula for sin hyperbolic n theta and the formula for 8 power n cos hyperbolic n theta. So that means your Z will be replaced by Z by a. So this is your Z square minus Az cos hyperbolic theta divided by Z square minus 2Az cos hyperbolic theta plus a square. So let us find out the Z transformation of these problems. Solution. The first part. Okay. Now use your damping rule. The Z transformation of 8 power n un was, now the Z transformation of 8 power n into un was u Z upon a. This is what we have proved in the dynamic rule. Now here you can see that if un is equal to if un equal to n, then the Z transformation, then first of all the Z transformation of n was, we have already got the Z transformation of n, and this Z transformation of n was Z upon Z minus 1 whole square. This was the Z transformation of, I think the Z transformation of n was Z upon Z minus 1 whole square. So we have the Z transformation of n. So now use this formula. So the Z transformation of n into n will be, now the Z transformation of n into n will be u Z upon a. That means this is your uz. Now the z transformation of 8 power n into un, means z transformation of an, un is your n, and this is equal to, now the z transformation of 8 power n into un is uz by a, where uz means the z transformation of un. In our case, our un is n, so your uz means the z transformation of un, means z transformation of n. This is your z transformation of 8 power n into un. Z transformation of 8 power n into un is uz by a, where my uz was the z transformation of un. Now here, if you put un equal to n, then your uz will be the z transformation of n. Now in our damping rule, our un is n, so that means this will be your equal to uz by a. That means we have to replace our z by a in uz. So this is equal to z upon a, 1 z upon a minus 1 whole square. So your answer will be az upon z minus a whole square. So this is your first part. For the second part, again use your damping rule. So a square, a power n into n square is equal to z into 8 power n into un, where my un will be n square, and the z transformation of this un was, and your uz was, and this was your z square plus z upon z minus 1 whole cube. Now by damping rule, this z transformation of a and un will be uz by a. So this is your uz by a. That means we will have to replace our z by z upon a. So this is your z upon a whole square plus z upon a upon z upon a minus 1 whole cube. So your answer is, now from here we will have a square, so 1a will be here. So this will be a square z upon z minus a whole cube. This is your answer. So this is your second part. Now let us solve the third part. Z transformation of cos n theta. Now cos n theta can be written as half e for I theta plus e power minus I theta. Now in place of theta we have n theta, so this will be e power ni theta plus e power minus ni theta. Now this can be written as half z transformation of e power I theta power n. Then here we can write it as z transformation of e power minus I theta power n. Now we have the formula for z transformation of 8 power n. The z transformation of 8 power n was, if you assume this e power I theta as a, then we have already the result for z transformation of 8 power n, and that was your z upon z minus a. Now in place of a we have e power I theta, so this is your z upon z minus a, and then again we will have z upon z minus 1.2. Now we can take the LCM. So this will be your z square here. Then we will have minus z e power I theta plus e power minus I theta, and then again z square. In the denominator we will have z square minus, again if you multiply this term by this term, then we will have minus z e power I theta plus e power minus I theta, and then this minus and this minus will be plus, and e power I theta into e power minus I theta will be 1. So now this is your 2z square, and e power I theta plus e power minus I theta will be your 2 times cos theta. So this will be 2 times cos theta into z divided by, again this is your z square and this will be your 2 times z cos theta plus 1. So our answer is z square minus z cos theta divided by z square upon 2z cos theta plus 1. So this is the answer for the third part. And the fourth one is similar to the third part, and the difference will be, here we will use the formula for sin n theta, and sin n theta means e power n I theta minus e power minus n I theta divided by 2i. So we will have minus sign here. So if we have minus sign here, then this will become your minus z square. So this z square and this z square will be cancelled, and here we will have minus e power I theta minus e power minus I theta, and we can use the formula for sin n theta. So the sixth part is also similar to the fourth part or third part, so I am not going to solve them. Fifth and seventh are similar to each other, so I am solving the fifth part. So solution for the fifth part, z transformation of 8 power n into sin n theta. So we can write it as z transformation of a n into un. We can also write it as z transformation of 8 power n into un, where un is sin n theta. Now by damping rule, this z transformation of 8 power n into un will be uaz, where uz is z transformation of un, and the z transformation of un means the z transformation of sin n theta, and z transformation of sin n theta is z sin theta upon z square minus 2z cos theta plus 1. So this uaz will be, now just replace your z by az. So this will be az sin theta upon a square z square minus 2az cos theta plus 1. So this is your answer of this part. And here you can see that this 8 power n into sin n theta was, let me cross check the answer. This was your, okay, I have done a mistake. This was your u z upon a. When there is a minus sign, then we get the u az, and as we have plus sign here, so this was your u z upon a. So we will have to replace our z by z upon a. So this is your z upon a sin n theta, sin theta on z upon a whole square minus 2 z upon a cos theta plus 1. So your answer is az sin theta upon z square minus 2 az cos theta plus a square. So this is answer of the fifth part.